In this video, we're going to learn about a different way of measuring angles called radians. So all we've ever known up until this point is how to measure angles in degrees. And we know that in a circle, we divide it into 360 little pieces and call the opening of those 360 pieces 1 degree. But why did we choose 360? Why didn't we choose 400? Or why can't we make up our own measure of an angle and say that I'm going to divide this into 3 different pieces and call it something else? Well, we can do that. So another way that we can measure angles is called radians. And radians sounds like the word radius. What do we know about the word radius? Well, we know radius is half of the diameter. So it's the measure from the middle of a circle all the way to the outside. What about around a circle though? How many radiuses would fit around the circle? Well, we have a formula for what fits around the circle, and that's circumference. And we know circumference is 2 pi r. So let's dissect what this actually means. That means that there are 2 pi radiuses around the circle. That's what 2 pi r means. What is 2 pi? We know pi is approximately 3.14. So 2 times 3.14 is 6 and a little bit. So that means there's one radius around the circle. There's another radius. So this is radius 2. Here's radius 3. Here's radius 4, here's radius 5, here's radius 6, and here's the little bit left over. So there's a total of 1, 2, 3, 4, 5, 6, and a little bit radiuses that are going to go entirely around a circle. So if we were to think about this as an arc, and the opening of that arc, we can call 1 radian. And the short form for radian is rad, R-A-D. So this is an entirely new way of thinking about angles. So our new measure of angles called radians is how big is the opening of an arc so that we can catch one radius around a circle. And that opening or angle is a radian. Sometimes it's easier to grasp radians when we think about half of a circle. If we know that there's 2 pi radians around an entire circle, how about just half of it? Well, what's half of 2 pi? It would be pi radians. So the entire angle here is pi radians. So think about what that means. That means that there's pi radiuses around this half circle. Pi is 3.14, so we have 3 and a little bit radiuses around the circle. So here's radius, or half circle. Here's radius 1, here's radius 2, here's radius 3, and here's that little bit left over. Because we have this lovely number or symbol pi to represent the number of radiuses around half of a circle, it's quite easy to actually label angles. So let's try this with the unit circle on the next page. So we've seen the unit circle before. We've used it with degrees. Now let's label it with radians to see if we understand it. So we know that here is where we're going to start. So here's where all angles are starting in standard position. So we're going to call this 0 radians. And we know halfway around the circle, how many radiuses will it take to get halfway around the circle? Well, we know that that's just pi radians. And how about the entire way around the circle? Well, that's going to be 2 pi radians. So this represents 0 degrees, also represent 2 pi. So think about it. What can we label this angle here? Well, we are half of a pi. So that means that we can label this pi over 2 radians. So what does that mean? That means that we can catch 3.14 divided by 2 radians. So we can catch about 1.5 radians right here. How about over here? Here we've gone an entire pi plus another half. So we can think of that if we were just counting a half. So we have a half pi, another half pi, that's going to make 1 whole pi. Then we have 3 halves. So this is going to be 3 half pies. Can we break this down even more? What if we try quarters? And by quarters, I mean quarter of a pi. So here's a quarter of a pi. Here's another quarter. Let's just highlight all the quarters. So if this is pi, and this is half pi, then this would just be a quarter of pi, which we know we can just write as pi over 4, or 1 pi over 4. How about the next one? Well, here's 1 quarter, 2 quarters, that's going to be a half, 3 quarters, so we can write 3 over 4 pi, 3 quarters of a pi. Here's an entire pi, 4 quarters. How about this one? That's going to be 5 quarters. It's going to be 5 pi over 4. How about the next guy? The next guy would be, after 5 quarters, would be 6 quarters, and that just simplifies to 3 over 2. Then we have 7 quarters, 7 pi over 4. And then, of course, 8 quarters, which would be 2 pi's. What about a third? So a third of a pi would be here. So here would be a third. Here would be another third. Let's just highlight all the thirds. So now let's continue to label. Here's a pi, and here's it divided into 3. 1, 2, 3. So this is a third of a pi. So we can just write pi over 3, a third of a pi. And the next one would be 2/3 of a pi, so 2 pi over 3. And the next guy here, a third, 2/3, this would be 3/3, and that just simplifies to 1. Now we have 4/3. We can write 4 pi over 3. The next would be 5/3. And then after that we would have 6/3, which is 6 over 3 is just 2. And now the last thing is we just have these little sixths left over. All right, so here we go. This is a 6, 2 6, 3 6, etc. So some of them are already simplified for us. So let's just fill in what we have left over. This is going to be a 1/6 of pi. So this little piece, if we multiply it by 6, would give us a whole half, which is pi. So the first guy would just be a 1/6 of a pi. So pi over 6. After that, it'd be 2 6. Well, 2 6 is just a third. We already have that. And 3 6. That's just 1 over 2. So we have these ones. So let's just count the ones that we're missing. So this is 1 6, 2 6, 3 6, 4 6, 5 6. So let's write 5 pi over 6. Keep on counting. We got 6 6. That makes sense. It's just 1. 7 6. Let's add 7 6 here. 7 pi over 6. Then we have 8 6, 9 6, 10 6, 11 6. So if we just think of it as part of pi, we can label a unit circle quite easily. So now that we understand radians, we can just answer these simple questions. How many radians are in 180? That means how many radiuses can we fit in 180 degrees? And we know that that answer is just pi. We can fit pi radiuses, therefore pi radians in 180 degrees. And how about 360? Well, we know that that just means we can fit 2 pi radiuses, therefore 2 pi radians in 360. So next we're going to talk about arc length. Because radius and arc length are related when we're talking about radians, we can make this ratio has to be true. The length of the arc divided by the length of the radius has to equal the angle in radians. That's the definition of what a radian is. Taking the arc length and asking yourself, how many radiuses actually fit in that arc length? That's going to give us the number of radians. So if this holds true, we're going to use this property to answer these next few questions. So it says the diameter of a circle is 30. So diameter isn't as helpful as radius. So immediately let's change that to a radius. There. The central angle measure is 120 degrees. 120 degrees is also not helpful to us when we're talking about radius. We want to change that into radians. And then it says find the length of the arc. So what we're talking about here is if we've got a circle here, 120 degrees is less than 180. It's just about here. So there's 120 degrees. And if you think about 120 degrees, it's 2/3 of 180 degrees. So it's 2/3 of 180 degrees. So 2/3 times 180 is going to give us 120. So if we were to change this into radians, it would just be 2/3 of pi. So that's how we would write it in radians. We're going to go through in just a couple of minutes a fast way to convert from radians to degrees and degrees to radians. But for now, because this is actually a number on our unit circle, this is easy for us to convert. So now we know what the angle measure is in radians. It's 2/3 over pi. We know what the radius of the circle is, it's 15. Therefore, we can figure out the arc length if we just fill in this formula. So we know that our radius, or the number of radians, is going to be our arc length divided by our radius. We know that the angle is 2/3 pi. Our arc length is unknown, and our radius is 15. So if we multiply by 15 on both sides, this guy will cancel out, and we're going to be left with the arc length equals, let's just simplify this really quickly. 15 times 2 is 30, divided by 3 is 10. So our arc length is going to be 10 pi. So the next example gives us an arc length. It says the arc length is 50 centimeters and its central angle is 2/5 pi radians. Determine the radius of the circle. So it's pretty simple. We're just going to use this formula. Try it on your own. Come back to the video to just make sure you've got the right answer. So if you're just checking your answer, use the formula that we derived up here, or we understand up here. Fill everything in. I cross-multiplied over here. If you did it a different way, that's fine. Cross-multiplied, and we get the answer of the radius equals 125 over pi. It doesn't make sense to change this into a decimal because we can only approximate this. This is the exact radius of the circle, 125 over pi, so leave it this way. Let's finish off by figuring out how we can very quickly convert angles from degrees to radians and from radians to degrees. So this is really our key. Remember that pi radians is the same as 180 degrees. So if we were to take pi radians divided by 180 degrees, that's really just 1. Same as if we were to take 180 degrees over pi radians, that's also just equal to 1. So we can use this ratio to help us convert very easily because we can just multiply by this guy or multiply by this guy, which is equivalent to multiplying by 1 in order to change these things. So for example, changing from degrees, let's start with 333 degrees. So this isn't a nice number. This isn't a nice number that's on our unit circle. So we can't just use it, figure this out by proportions. So instead, let's multiply it by one of these ratios. So I want the degrees to cancel out. So it wouldn't make sense to be multiplying by 180 degrees. It would make sense to divide by 180 degrees, so that degrees go away. So I'm going to multiply it by pi over 180 degrees. So this is pi radians over 180 degrees. So by multiplying these two, I have degrees divided by degrees. So those are going to cancel out. So in my calculator, I'm going to put 333 times pi divided by 180. And what I get is approximately, let me just change my pen to black, approximately 5.81 radians. Okay, so it's not exact, it's approximate because I had to round here. And does this make sense before we move forward? Think about where on the circle 333 degrees. It would be almost around the entire circle, but 30 more degrees to go approximately. So does this make sense? That it's 5.81 radians. We know all the way around a circle is 6 and a little bit radians. This is almost 6, so this makes sense. So let's keep going. Let's try 124 degrees. So I want the degrees to cancel out, so let's just multiply it by pi over 180. So we have pi radians, so we're left with the unit of radians, over 180 degrees. Those degrees are going to cancel out. And in my calculator, I'm going to put 124 times pi divided by 180. And we get approximately 2.16 radians. Does this make sense? Well, we know 124 degrees is between 90 degrees and 180 degrees. So 180 degrees, that would be pi radians, which is just over 3. So less than 180 is 124, so 2 radians is over 2 makes sense because it's less than 3. let's convert some radians to degrees now. So if I take a look at this guy right over here, radians, this is 6 pi over 4 radians. So we can rewrite this as 6 over 4, 6/4 of a pi, which we know would just can be reduced to 3 halves of a pi. But can we think of a really easy way to convert this? Well, isn't pi just equivalent to 180? So can't we just write this as 6/4 of 180 degrees and seeing what that equals? If you throw it into your calculator, it's just 270 degrees, which we could have predicted because we know that 6/4 is 3 halves, and 3 halves of pi is going to be 270 degrees on the unit circle. So that's actually really an easy way to convert from radians to degrees when we have a pi there, because we know it's equivalent to pi, just 180. How about if there isn't a pi, though? Taking a look down here, well, we can use our little ratio that we came up with. So if we take 6, and we know that that measure is in radians, and we multiply it by 180 degrees over pi radians, I'm really just multiplying by 1 because 180 degrees in pi radians is equivalent to the same thing. So it's 1. The reason over here I put radians over degrees because I wanted the degrees to cancel out to get radians. Here I want the radians to cancel out to get degrees. So I flipped our ratio that we used over here. So now we have radians over radians. The radians are going to cancel out. And into my calculator, I'm going to put 6 times 180 divided by pi. And I get approximately 343.77 degrees. Does this make sense? Well, 6 radians, that's 6 radiuses around the circle. We know around an entire circle is going to be 6 and a little bit, 2 pi. So it should be pretty darn close to 360, and that's what it is. It's 343. So now try these last 4 on your own and just come back to the video to check your answer. So here are our final answers. Check to make sure you got the same.